Okay, next up, this is video 4. We have a function of t, and then t is a function of x. F is a function of t, but t is a function of x. So we have a composite function. We need to employ the chain rule. Let's use the d notation. In order to get f's derivative with respect to x, what we do is we get f's derivative with respect to t, and we multiply that by t's derivative with respect to x. Kind of like think about these two canceling out. And so df dt, the derivative of f with respect to t, you carry down the 5, you bring the -4 out of the exponent, and then you take t and you raise it to 1 less power. You take away 1 from the exponent. Well, -4 take away 1 is a -5. And so that's going to be a -20 t to the -5. And then we have to take the derivative of t with respect to x. Well, sine's derivative is just cosine. And so we take and multiply this by cosine x. Now your answer should not have a mixture of variables like this. Although some of these answers do have a mixture of variables. I guess our answer is not A because of the fact that there's a t inside of there. It is not B for sure. These two different parts, that's thinking about product rule or something. I guess this letter D is just a rewrite of the original function. And so what we're looking for then is letter E. And the reason being is that we're going to replace the t with sine x. So we're going to have this -20, and then sine x is raised to the -5th and is times cosine x. For you to have the derivative of f with respect to x, all your variables should be in terms of x. And so that's why letter E is the answer. Now, we have a function f who is 3 to the x. This is an exponential function. Their derivatives are a repetition of them. F prime of x is just going to be 3 to the x. But there's an extra part to that we need, which is to multiply by the natural log of whatever the base is. In this case, the base is a 3. And so if your function is 3 to the x, your derivative is 3 to the x times the natural log of 3. Okay, great. And then g dx, g of x is just some polynomial x to the 5th plus a 4. So g prime of x is just going to be like 5x to the 4th. Okay, and we just have to do product rule. This is two functions multiplied together, so product rule. We're going to have d dx on f times g to be f prime of x times g of x plus f of x times g prime of x. And we'll just cut the pieces and paste them in from above. We have the derivative, which is 3 to the x times the natural log of 3 times g, who is x to the 5th plus 4. Then there's a plus sign where we leave f alone, and we multiply by g's derivative, who is 5x to the 4th. And that matches one of our answers. D, letter D. They just put the ln3 out front. ln3, 3 to the x to the 5th plus 4, plus sign, and then they put the 5x fourth first, but it's all the same. That's letter D. Okay, product rule, but with an exponential function. Now these are different. These aren't exponential functions. These are power functions. We have x to the fifth and x to the 1.2. And we got to combine into this formula 2 times x to the fifth minus 3 times x to the 1.2. Let's just go ahead and plug them in. Consider that your function h, and you want the derivative of that. So h prime, keep the 2, bring down the 5 and take x to the 4, keep the negative 3, bring down the 1.2 and take x to the 0.2. That's it. And so 2 times 5 is a 10, x is to the 4. If you triple 1.2, you get 3.6. And then x is to the 0.2. And there's your derivative. I think it's letter A. Sand is being dumped into a pile whose volume is pi over 12 h cubed. It's the volume based on the height of the pile. They don't say what kind of pile it is. Okay. The height of the pile in meters. So this is in meters cubed, and height is in meters. So this tells you the volume given a height. At noon, the pile is 5 meters tall. At noon, h is equal to 5 meters. The height is growing. That's a derivative, a rate and growing means positive, and 0.4 is going to be the meters per minute. At what rate is the volume of the pile growing at noon? They want us to find dV dt. Okay, so we take the derivative. We have this pi over 12, and we carry that down. It's a constant. H cubed's derivative is 3h squared. But h is changing with time, so we multiply by dh dt. And so we're going to have, let's see here, that can be pi over 4. So we have pi over 4 times h who squared times dh dt, who is 0.4. I want to use the fraction version, 2/5. And so, but h is 5. So we have pi over 4, 2 over 5, and then 5 squared. That's what dV dt is. Now these answers are in decimal format, so this 5 can cancel one of those 5s. This 2 can cancel that 4 and turn into a 2. And it looks like we have 5 pi over 2 is what dV dt is. And so we would need a calculator at this point to figure out. It's like taking 1.5 times 5. I believe it's 7.85 given these answers, but let's go ahead and do a calculator, quick calculator answer to this. So we take pi and times it by 5 and then divide it by 2. Yeah, it's 7.85. And the units are meters cubed per minute. Letter B. Okay. All right, great. Let's stop right there, and then we'll do the last video probably on the fill in the blank derivatives.